My name is Yujin. I'm the host of the show. Today we're going to be talking with Chang from Lance.
Previously, if with tabular data, if you had, like more than 10 petabytes of data, you were on a short list of internet companies that everyone knew about.
Yeah.
And today, if you're dealing with multimodal data, like there are startups that are dealing with petabytes of data and that like are just starting out. So the data scale is huge. The processing is very different and the needs are also very different. So with tabular data, most of the time, the vast majority of workloads were OLAP sort of workloads,
Okay.
or only for smaller scale tabular data, you're looking at like Postgres or like OLTP type of workloads. But with multimodal data, it's like you need the OLAP stuff. You also need to do search and retrieval, and then you also need to do things like distributed training. And so the workloads are a lot more diverse, right? So we go from one dimension of requirements to maybe three. So your system needs to be good at like the OLAP stuff for fast scanning through the data.
Okay.
Your data needs to be good at like random access so that you can do search and retrieval.
Uh-huh.
And you need to be able to manage large blobs effectively. So for distributed training, for just overall data management, so you need that as well. And so if you look at existing systems, it pretty much is that all of them are good at like at most two, but most of the time just one of those three criteria. This is what I call the CAP theorem for AI data. Parquet is generally really good for fast scans, but it doesn't support random access. And your relational database systems are good for random access, but not good for fast scans or like large blob storage. TF records, for example, is the TensorFlow format. It's specially made to deal with large tensors, but then it's not very good for any of the other ones. So there are various systems that you may or may not have heard of that are like sort of in between the boundaries for between two of them, but there's nothing sort of in that middle that really hits home for all of the needs for multimodal data. And that's the motivation for us to create Lance format in the first place, is to, instead of having to pick, like you can have your cake and eat it too.
Okay. So Lance is able to do all three of the OLAP kind of stuff, the random access, and having big blob storage.
There's a bunch of changes and differences between the Lance format, columnar format, and Parquet.
Mm-hmm.
Some of the biggest differences are in the encodings, so that you don't have to read out a whole row group in order to get to one row. So that gives you the ability to do random access. We've actually gotten rid of row groups altogether in the latest like Lance v2.
Okay.
And the reason for that is when you have multimodal data, you might have one column that's very big, and then you might have other columns that are very small, right? So like, basically you have metadata that are like floating point numbers or IDs, and then you have images and videos. And when you have row groups, what that does is it makes it really difficult to tune your data set, so that you have to choose between large row group sizes that are really good for doing scans on the small columns, but make it difficult to deal with the large columns, or you choose, essentially like one image per row group or one video per row group, but make it really difficult for scans to manage the smaller columns. So now we're able to, because it's columnar, we can still deliver fast scans. It now supports random access, and because we've gotten row groups, it supports large binaries much easier, right? And once you have all three in this one data format, you can now do various things. So, for example, previously with Parquet, there were various projects and extensions around indexing.
Uh-huh.
And that didn't really take off, partly because Parquet didn't support random access. So your index can tell you very quickly, based on some search query, like which rows you need to fetch. But if fetching those rows takes a long time, the speed up you save from the indexing is not as significant. but Lance is different because we support random access. So now if we can say, like, if you enter a query, a vector query, our index can point to the right rows in a couple of milliseconds, and then the actual fetching of the rows takes a few more milliseconds. Well, now you've got a real-time serving system for vectors, for vector search, out of just a file. And so that's some of the things that's almost like emergent behavior of, like, once the foundation is correct, it gives the use cases and the database systems on top of that a lot of room to play with, that delivers performance in places where, like, previously it was not possible.
I want to kind of dig into one of the things that you mentioned, which was this kind of ability to do random access. And I think you mentioned, so first you were saying something about row groups where you don't need row groups. And one of the reasons why row groups are a drawback for this type of data is that you have different, like, I guess, sizes of columns. And so when you say random access, are you talking about the ability to pick, like, hey, here's my row, here's my column, pick out whatever entry is here? Or, okay, and that entry would be like a vector.
Right, yeah, so that entry would be vector. So the fast access to columns is guaranteed by the columnar format,
Okay.
right? But it's the fast random access to rows that's sort of the secret sauce here. So the idea is, let's say you have a vector index that says, okay, the 10 closest vectors to your query is, like, row 2 and 10,000 and, like, 2,554, right? So, like, spread out your data set. When you have row groups, it means for each row you have to read out whatever that whole row group is. So
Oh,
typically, if your row groups are, like, a couple of thousand or 10,000, for floating point numbers, it's not the end of the world to read out a block like that. But for vectors and larger data types, that becomes prohibitively expensive.
okay. Okay. So if I'm